All right, so in this video, I'm going to start with example number 3 in the integration by parts packet that I gave you. Um, I want you to realize that most of the difficulty that you're going to have when figuring out which anti-differentiation method to choose is which method to choose. So when you're trying to anti-differentiate, the issue is going to be like, is it an easy antiderivative? Is it U substitution or is it integration by parts? So what I normally do is I look at the problem and I say, do I have an integral rule for this? If I don't, is there a little bit of algebra that I can do to integrate it? So like, for example, if this 8 wasn't here, then I could FOIL this out and it would be very easy integration. This is to the 8th power. There's no way I'm multiplying this out 8 times and then distributing x minus 2. So this is not a rule that I know, and it's not easy integration. Okay, it's not like algebra will fix it. So the next thing I do is I literally try U substitution, okay? Because I don't want to do parts if I don't have to. So what I would do is I would use my rule for U substitution that says, if you have a base to a power, then let U be the base. So I'm going to say, okay, let's just let U be x plus 4. And then my du would be dx. And then I'm going to say, all right, if that's true, let's rewrite the original in terms of u's. So my integral would be u to the 8th times du. And if I check back, that takes care of this whole thing, and my du takes care of this. Now what I have left over is x minus 2, which looks like a problem, but it's actually really not, because I can solve this little statement right here for x. And if I do that, then I get x is equal to u minus 4. Well, what I actually have in here is x minus 2. So you can do this one of two ways. I like to just say, so then x minus 2, I'm just subtracting 2 from both sides, is equal to u minus 6. And if that's confusing, then just write it in the parentheses. Just write x is u minus 4. So just go u minus 4, and there was still a minus 2. So I'm rewriting x in terms of u. Well, x is u minus 4 because u is x plus 4. So x is u minus 4. So then if I put in u minus 4 for x, I still have to subtract that 2. And if I clean this up, I end up with u minus 6 times u to the 8th du. And then what you can do is just distribute this, okay? And now it's a nice, easy integral. So this is u to the 9th minus 6u to the 8th du, okay? And then I can go ahead and integrate that. So that would be u to the 10th over 10 minus 6 u to the 9th over 9 plus c. And then if I back substitute, I get x plus 4 to the 10th over 10 minus, this simplifies to 2/3, so 2 times x plus 4 to the 9th over 3 plus c. So don't try integration by parts first, even if you're doing a worksheet on integration by parts, okay? Try to see if it's easy, try U substitution, and then if all else fails, it's time for integration by parts, okay? So now let's give another one a shot. So this is going to be example number 4. So example number 4 says, integrate x squared e to the x dx. Okay, so if I were going to do U substitution, sometimes we know that there's an integral rule, e to the u du. So you would be like, okay, let u be the exponent of the e power, right? But that would have us writing u equals x for u substitution. And remember, for u substitution only, you never want to write u equals x. The other option is, remember, if we have something to a power, let the base be u, but there we go again, u equals x. So it doesn't look like u substitution is going to work. So this is probably integration by parts. So if we're going to do integration by parts, it's honestly pretty much a guess here. Whatever you pick for u has to be easy to differentiate, okay? So I'm going to put my picks in blue, and I'm going to put my gets here. We'll do it with letters, so we'll do it like this. I'll put my picks in pink, so pick is going to be in pink, and my gets are going to be in green. So I'm going to pick u, I'm going to pick dv, I'm going to get du by taking the derivative, and I'm going to get v by taking the integral, okay? And remember, the formula is the integral of u dv, my picks, is equal to u times v minus the integral of v du. Okay, so we have to rewrite this original just using u dv. So I'm just going to take a stab in the dark, and I'm going to pick x squared as u. So I'm going to go x squared for u, and then for dv it has to be the rest. So then dv would have to be e to the x dx. All right, let's see if that is a good move. So the derivative of x squared is 2x dx, and the integral of e to the x is e to the x. So let's see what happens when we plug that in. So just check that u dv is equal to the original. So if you take x squared times e to the x dx, that is the original. So we're good. So this is equal to uv, so u v minus the integral of v du. All right, so that doesn't look great. And I definitely cannot integrate this the way it is. Like, I don't know a rule for what this is. I'm going to clean this up a little bit, and we'll kind of look at it some more. So this is x squared e to the x minus, I'm going to pull this 2 out in front of the integral. So minus 2 integral x e to the x. So I can't take the integral of x e to the x. Like, I don't know that, right? But I do have things I can do, and this is what's unfortunate about this. But let's just go back up a second and compare that to the original. So the original was the integral of x squared e to the x. So like, this got better. I mean, it's not, I can't do it like right away. I can't just say, oh, the integral is this. I have to do something else. But I did get it to go down an exponent. So that's actually helpful. You might not think it is. It's like, okay, well, I didn't do anything. Yeah, you did. You made it easier. And what you actually have to do, and this is important, you have to integrate by parts again. Okay, so if this happens and the degree goes down, and you're like, sweet, but you just have to do parts again. So it's parts again. So the exponent is going to go down. It's going to look a lot like it did to start, and you just have to go parts again. So watch. We're going to do this one more time. So pick in pink. So u dv, and then get in green. du v. All right. So I'm going to go with my same strategy. I let x squared be u last time, so I'm going to let x be u. Now you're like, you said never to let x be u or u be x. That's only if you're doing u substitution. In parts, this is a really, really, really common substitution, okay? So in parts, you do let u be x a lot. That sounds weird. Okay, so That means that if I use u for x, then my dv has to be e to the x dx. So this is e to the x dx. All right, so I'm going to go derivative this way, right? So I'm going to take the derivative. So the derivative of x is dx, and then I'm going to integrate this way. The integral of e to the x is e to the x. So this is e to the x. All right, so let's see what we get. Now, the other thing you're going to forget is to bring this guy along for the ride, because this part right here was just me working on this integral, okay? So this guy's still there. So I'm going to kind of just like draw an arrow and bring him down here, and I'm going to write him out. So x squared e to the x. He was from the first part, so kind of just hang out over there. All right, so it's uv minus v du, right? So don't forget you've got that minus 2. So here we go. It's minus 2, and then your parts formula. u v minus the integral of v du. And look, we stuck with it and kept going, and now we can integrate this. This has a rule. So what we did is we slowly chipped away at the exponent to bring it down each time, and now we've brought it down to something that we can actually very easily integrate. So just bring this guy along for the ride again. So we've got x squared e to the x. This minus 2 I'm going to distribute. So minus 2x e to the x plus 2, because I distributed. And the antiderivative of e to the x is e to the x. And then you can go ahead and throw a plus c on the end. Okay, so you definitely have to be able to do integration by parts with repeated parts, okay? And that's how you do it. So what you need to do now is work on 1 through 10 on integration by parts, okay? There are a couple where you have to do parts twice. And I don't want to tell you which ones those are, but you definitely have to make sure that you practice these. Okay, so good luck, and then on Monday, you can let me know if you have any questions.